Hello students, in today's video we will learn about equivalence relation. So first let us define reflexive relation. Let A be a non-null set. A relation R on A is said to be reflexive if AA belongs to R for all A belongs to A. So let's understand this with help of an example. Suppose A is equals to 1, 2, 3. Then a relation R that is defined as 1, 1, 2, 2, 3, 3 and 1, 2. Then R is a reflexive relation. Why? You see that what is the definition of a reflexive relation? That AA must belongs to R for all A belongs to A. In this example, you observe that 1 belongs to A, so 1, 1 belongs to A, and 2, 2 belongs to R, and 3 belongs to A, 3, 3 belongs to R. Since for all elements in A, the ordered pair AA belongs to R, so R is a reflexive relation. If we define R1 is equals to 1, 1, 2, 2 and 3, 3. This is also a reflexive relation. You observe that R1 is identity relation. We can say that identity relation is always a reflexive relation, but not all reflexive relation is identity relation. Not all reflexive relation is identity relation. Consider the relation R is equals to, suppose 1, 1, 2, 2, 3, 3 and 1, 2. This relation is reflexive. Why? Because all the terms AA belongs to R for all A belongs to A. But this is not an identity relation because the term 1, 2 belongs to R. In order to be an identity relation, the terms like 1, 2, that is x, y, where x not equal to y, cannot belong to R. In order to be an identity relation. So, identity relation is always reflexive, but not all reflexive relation is identity relation. Now let's see some more examples of reflexive relation. Suppose A is equals to 1, 2, 3, 4. Then the relation R1, that is defined as 1, 1, 2, 2, 3, 3, 4, 4 and 1, 4, 2, 3, 3, 4. This is a reflexive relation because for all A belongs to A belongs to R. We can see it clearly that 1, 1, 2, 2, 3, 3, 4, 4, all the terms belongs to R1. So R1 is a reflexive relation. Now see a non-example. Suppose R2 is equals to 1, 1, 1, 2, 1, 3, 2, 2, 1, 4. Then R2 is not a reflexive relation. You see that 3 belongs to A, but the term 3, 3 doesn't belongs to R2. Also 4 belongs to A, but 4, 4 doesn't belongs to R2. So it is not an reflexive relation. Now consider an example. Suppose R be a relation that is defined as xy such that x divides y, where x belongs to n and y belongs to n. N is the set of natural numbers. Then R is reflexive relation. Why? Because for each natural number, that natural number divides itself. That is x. If x is a natural number, then x divides x. So the ordered pair x belongs to R. Therefore, for all x belongs to n, x belongs to R. Hence, R is reflexive relation. Now we consider a non-example. Suppose L be the set of all straight lines in a plane. R be a relation on L, and R is defined as the ordered pair L1, L2 such that L1 is perpendicular to L2. Then R is not a reflexive relation. Why? Because we know that no straight line is perpendicular on it. That is, L1 is not perpendicular to L1. So the ordered pair L1 doesn't belongs to R. Hence, R is not a reflexive relation. Till now we have seen some example and non-examples of a reflexive relation. Now let us define a symmetric relation. Suppose A is a non-null set, then a relation R on A is said to be symmetric if AB belongs to R implies BA also belongs to R. That is, if the ordered pair AB belongs to R, then the ordered pair BA also must belong to R. So let's see some examples. Consider A is equals to 1, 2, 3, 4 and the relation R is equals to 1, 1, 1, 2, 1, 3, 2, 1, 3, 1. This relation is a symmetric relation. Why? Because 1, 2 belongs to R and 2, 1 also belongs to R, 1, 3 belongs to R and 3, 1 also belongs to R. That's why R is symmetric. Now let's see a non-example. Suppose R1 is equals to 1, 1, 1, 2, 1, 3, 3, 1. Then this is not symmetric. Why? Because 1, 2 belongs to R1 but 2, 1 doesn't belongs to R1. But from the definition of symmetric relation, we see that if AB belongs to R1, then BA must belongs to R1, but 2, 1 doesn't belongs to R1. So this is not a symmetric relation. Now consider, suppose L be the set of all straight lines in a plane. Now define R on L such that R is equals to L1, L2 such that L1 is perpendicular to L2. Then R is a symmetric relation, because if L1 is perpendicular to L2, suppose L1, L2 belongs to R. So this implies L1 is perpendicular to L2. Now this implies that L2 is perpendicular to L1. So this implies L2, L1 belongs to R. So L1, L2 belongs to R implies that L2, L1 also belong to R. That's why R is a symmetric relation. Now consider the relation R on the set of all natural numbers n defined as R is equals to xy such that x divides y, where x belongs to and y belongs to n. So this is not a symmetric relation. Why? Because you see that 2 divides 6, so 2, 6 belongs to R, but 6 does not divide 2, so 6, 2 does not belongs to R. So R is not a symmetric relation. So we see some examples and non-examples of a symmetric relation. Now this video is already very long, so I will define the transitive relation and equivalence relation in the next video. Thanks for watching.